prime factorization. Let's break it down. Today we're learning all about primes. If you're thinking of a franchise that features sentient robots from outer space, go ahead and reel that back in for me. These primes are different. We're talking about numbers that can only be divided by that number and 1, like 5. 5 is a prime number because it can only be divided by itself and 1. 2 is also a prime number. In fact, it's the only even prime number. Why? Because every other even number is going to be divisible by at least itself, 1, and 2. So with the exception of 2, all prime numbers are odd. 1 doesn't count as a prime number. Technically, it's divisible by itself and 1, but they're the same thing, so that's cheating. You need to be divisible by 2 different positive whole numbers to count as prime. If a number isn't prime, it's composite. Composite, as in composition or composed, because those numbers are composed of other numbers. See? Sometimes names make sense. 1 isn't composite either. Your only composite of 2 whole numbers that aren't 1 can multiply together to get you as an answer. 1 truly is the loneliest number. The list of prime numbers goes on literally forever, but the first several are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and 31. It's important to get comfortable recognizing these early primes because they'll help us with what comes next. And what comes next? I'm glad you asked. You've probably heard the term prime factorization. It sounds like something a mad scientist cooked up in his basement, but it just means you're breaking a number or term down into its smallest pieces to make it easier to work with. When you're done, you'll be able to rewrite the original number or term as a product of prime numbers. I'll show you my favorite way to do this, and in just a minute you'll see that it's actually really easy, and it will make the rest of your work easier as a result. We'll start by finding the prime factorization of 9. We start by writing 9 at the top of our workspace. We know that 9 is divisible by itself and 1, but it's not on our list of primes, so we know it must be divisible by something else as well. It isn't divisible by 2 because it isn't even, but it is divisible by 3. 9 divided by 3 equals 3, so our factors, the numbers we multiply together to get 9, are 3 and 3. We're going to turn our 9 into a little tree by drawing branches out from the bottom, and at the end of each branch, we'll write a 3. This is how we represent the fact that 9 is the product of 3 and 3. We've got a prime number at the end of each branch now, so nothing can be divided further. Our prime factorization will be written as a list of the numbers at the end of our branches being multiplied together. In this case, the prime factorization of 9 is 3 times 3. 9 was easy, but what if we end up with a more complicated number? First things first, don't forget to stay organized. Start with the smallest prime, 2, and divide by 2 as many times as possible until you have a 2 at the end of each branch or another prime number, and you can't divide any further, or until the remaining non-prime is not even. Then move on to the next prime, 3, and divide by that as many times as possible. Then 5, 7, 11, and so on, until every number at the end of a branch is prime. If the non-prime number you're trying to divide isn't familiar, and you're not sure if it's divisible by a prime, you can check by putting it into a calculator. If the result is a whole number, good news, it's divisible by that prime. If there's a decimal or you end up with a fraction or a remainder, your number isn't divisible by that prime. Here are a few simple rules to help you when you're checking for divisibility. If a number is even, it's divisible by 2. If the digits of a number add up to 3, 6, 9, or any other multiple of 3, that number is divisible by 3. If a number ends in 5 or 0, it's divisible by 5. Keeping these in mind, let's find the prime factorization of 36. This one is bigger than 9, but we're going to handle it the same way. Start by writing 36 at the top of your workspace. Now, check to see if you can divide 36 by 2. It's even, so yes, we can divide by 2. We'll be left with 2 at the end of one branch and 18 at the end of the other. 18 is still even, so we'll divide by 2 again. We'll add branches under 18 with 2 at the end of one branch and 9 at the end of the other. 9 isn't even, but it is a multiple of our next prime, 3, so we know we can divide by 3. Draw branches under 9, and because 9 divided by 3 is 3, we'll put a 3 at the end of each new branch. We're left with nothing but prime numbers at the ends of our branches, so we know we're done. The prime factorization is 2 times 2 times 3 times 3. You can always check your work by evaluating the prime factorization. 2 times 2 equals 4, 4 times 3 equals 12, 12 times 3 equals 36. Our answer matches the number we were trying to factor, so we know our work is accurate. All right, we've covered the basics. As a treat for sticking around, I'm going to leave you with a list of every prime number between 1 and 100. This will help you if you end up with an even more complicated number. If you feel like you need more practice, hop on over to the Prime Factorization Examples video and we'll work through a few more numbers together.